Hey students, this video is going to cover factoring all kinds of trinomials. So let's get started. We have 4x squared minus, you know what, start over. No. Let's give them an explanation. So a trinomial, I'm assuming you all meant quadratic when you meant factoring. So a quadratic trinomial is going to be ax squared plus bx plus c. This is the thing that we're factoring. So now, um, let's look at a specific example. So we have 4x squared minus 12x minus 7, and we want to factor this. So if we want to factor, we need to use the factors of the first term and the last term. So that means we're going to take this 4x squared and the negative 7, and we're going to multiply them. So we get 4x squared times a negative 7, and that's going to give us negative 28x squared. And so we haven't, so the negative 12, that comes up from the factors of negative 28x squared that will add to be negative 12. So you do have to have some numbers in. So we have to have 1 and 28 as factors, or you have 2 and 14, or you have 4, you have 7, and then they start to repeat. So obviously 1 and 28 don't work. Obviously 4 and 7 don't work. So now with 14 and 2, we can get a negative 12 if the 2 is positive and the 14 is negative. So we're going to have a negative 2x and a positive 2x and a negative 14x. All right, I can write. Trust me, I can write. So positive 2x, go back to the pencil, a positive 2x and a negative 14x. And so we rewrite the negative 12x term as these two terms. Make that a little brighter. So now we're going to rewrite this as 4x squared plus 2x minus 12x minus 7. I know you're wondering, does it matter if I write the 2x or the negative 12x first? The answer is no, it just factors slightly differently, but we still get the same answer. Um, so next we're going to group. So we have 4 terms. We're going to group the first 2 terms and we're going to group the last 2 terms. So when we group these 2 terms and we group the last 2 terms, what we want to take out is the greatest common factor for each one of those groups. And the greatest common factor for 4x squared and 2x is going to be 2x, and that's going to leave you with 2x plus 1. And then the greatest common factor for that should be, I'm sorry, I made a crazy mistake. Nobody's perfect except for Rihanna. This should be 14x. Let me put in a 14. I'm sorry. So then the greatest common factor for negative 14x and negative 7 is going to be a negative 7, and then we would still have 2x plus 1. After this, we have a second group where we have a second step where we can apply grouping. We have one term is 2x times 2x plus 1. The other term is negative 7 times 2x plus 1. And because both terms have 2x plus 1 in common, we're going to just take out the 2x plus 1, and that's going to leave the 2x minus 7 as what we take out. So our factored version is 2x plus 1 times 2x minus 7. So again, that process, if we're starting over, the first step is to multiply the x squared term and the c term. So we have So we're really multiplying ax squared times c. That's our first step. And so that's how we got the negative 28x squared. After that, we found the factors of this negative 28x squared that would add or subtract to give us negative 12, which is how we got 2x and negative 14x. And after that, we grouped the first two terms, we grouped the second two terms, and we got a greatest common factor of 2x, and we got a greatest common factor of negative 7, and then we took out the common factor of 2x plus 1, which again gave us our final answer of 2x plus 1 times 2x minus 7. So the next example we're going to do requires us to first pull out a greatest common factor. Let me move this and create a new note. Move this thing for a moment and move it back to the top. All right, so next, say we have 6x squared. So we're going to write 6x squared minus 15x plus 6. So the first thing you should do if you factor anything is look for a common factor. The common factor for 6x squared minus 15x plus 6 is a 3. So we can take out a 3, and that's going to give us 2x squared minus 5x plus 2. And for a moment, don't worry about the 3. It's just going to be in our final answer. So next, we want to do the same process we did on the previous problem, which is multiply the 2x squared, a positive 2, and that's going to give us a positive 4x squared. And then we need to write the factors of 4x squared. That's going to be 1x and 4x, or 2x and 2x. And so if the factors have to add to be negative 5x, now clearly the 2x and the 2x won't work, so we'll use a negative 1x and a negative 4x. And so that's going to give us 3 times 2x squared minus x minus 4x plus 2. Next, we want to group the first two terms, and we want to group the last two terms, and the greatest common factor is going to be x. So we're going to have x times 2x minus 1 for that first group. And again, when you lead with a negative, you have to factor a negative out of that group. So we're going to have a minus 2 times 2x minus 1. And we still have that 3 in the front, so we'll put a 3, and technically this stuff is in parentheses. And so next, we want to pull out the common factor of each one of those groups, which is going to be the 2x minus 1. So we're going to have 3 times 2x minus 1, and then x minus 2. If that looks confusing to you, allow me to take out the parentheses in this first step here. Take out that. We take out that. So again, the process: multiply the ax squared term and the c. Find the common factor. Find the factors that will add to be the middle term, and then split factor by grouping twice. In our next example, we have a perfect square trinomial, but it's still going to factor the exact same way. In case you forgot what a perfect square trinomial is, I will quickly show you. Perfect square trinomial would be if we had something like 3x minus 2 times 3x minus 2. It's just the same thing twice. And when you multiply this out, you would get 9x squared minus 6x minus 6x plus 4, which is 9x squared minus 12x plus 4. So that's a perfect square trinomial. Now, you won't know that necessarily if you see it, and I highly just recommend you factor everything the same way. So pretend we don't know any of this, but you encounter what in the end will be a perfect square trinomial. So let's look at an example of that. So say we have 4x squared plus 20x plus 25. So I'm telling you this is a perfect square trinomial. We're going to have the same factor twice at the end, but let's see how we get there. So what's some color we haven't used? Ooh, let's use a nice bright, let's go with this purplish color. So we're going to take the 4x squared and the 25 and multiply them. That's going to give us 100x squared. And so we're looking for factors of 100x squared that can add to be 20. So there's some stuff we can obviously eliminate: 2 and 50, 4 and 25, 1 and 100. I would bet 10x and 10x are going to work for us. So both of them need to be positive. So we're going to have 4x squared plus 10x plus 10x plus 25. So a good indicator that it's a perfect square trinomial is when the factors that work are exactly the same thing, or when the number that you multiply, when the number that you get is a perfect square. That's going to be a pretty big clue if the other two numbers are also perfect squares. So we get 4x, I'm sorry, I need to factor out a greatest common factor. So we're going to take out, we're going to group the 4x squared and the 10x, and we're going to group the second 10x and 25. We take out a common factor of 2x. That's going to give us 2x times 2x plus 5. And then when we take out the greatest common factor for 10x and 25, we're going to get 5 times 2x plus 5. So we have a common factor of 2x plus 5 for both of those terms. So we're going to take that out. So we get 2x plus 5. And if we take out the 2x plus 5, that's going to mean that we have 2x plus 5 left over on the outside. So our factored version is 2x plus 5 times 2x plus 5, which means this is a perfect square trinomial. The next example and last example is, what if you had a difference of perfect squares? So say we have 4x squared minus 25. So the first thing I would do is rewrite this as 4x squared minus 0x plus 25. Now, if you remember a difference of perfect squares, it's just the square root of the first term plus and minus the square root of the second term. So this should be 2x plus 5 times 2x minus 5. And if you're thinking, oh yeah, I remember, I'll show you how we get here if you forget that. So anytime you forget the tricks, this factoring method works. So you always just have to have a trinomial, which means we need 3 terms. So if we multiply 4x squared and 25, that would give us 100x squared. And then the factors of 100x squared that will give you 0 means that the factors have to cancel out when you add them, which means they have to be inverses of each other. So the only ones that are going to work are going to be 10x and 10x, but one is positive, the other is negative. So we get 4x squared plus 10x minus 10x plus 25. And so the same process, we group the first two terms, we group the last two terms, we take out a common factor of 2x for the first, so we get 2x times 2x plus 5, and then the negative 10x plus 25 have a negative 5 in common, so we take out a negative 5, and we get a positive 2x minus 5 plus 5. I made a mistake. So 2x plus 5 is the common factor. So we would get 2x plus 5 and 2x minus 5 as our answer. And we already knew that. We said it all the way up here is that's what we would get. So this is how we factor a trinomial. We multiply the x squared term, you multiply the c term. You find factors of the ax squared times c that will add to give you that middle term of, in this case, 0x, and then you factor by grouping twice.